Okay, good evening everyone. Welcome to all the tech enthusiasts present over here, physically and virtually. I welcome everyone on the behalf of thingQbator TAT. Before moving towards the session, if everyone can turn on their cameras and I can get a raise of hands or any kind of emotes to check if you are guys really excited for this event. This is something we come across every day. We use many kind of devices that are somewhat IoT based, and we also in this prototyping stage we are we are doing many kind of projects which are IoT based, which requires hardware components to inside it to connect it to the internet, making something and making many more things. So this is the kind of importance nowadays we are having for this IoT, and I am blessed that we are getting this opportunity to get a webinar, and further in this webinar we have something interesting for you guys, those who are present over here in the virtual mode and those who are present over here in the physical with us. It's a very interesting journey we are going to experience. So I hope everyone is also excited. So as we know that our today's topic is IoT and its application. So to enlighten us on this topic with us, we have a very eminent personality which have more than 30 plus years of experience in this IoT field, and he is an experienced worker in mining also. So he is a spokesperson in our thingQbator TAT. So without a further ado, I welcome Mr. Dr. Abhay Kumar Samal, who is Dean School of Computing at Trident Academy of Technology and a very experienced person in the field of IoT. So I would request Abhay sir to take over the session and start it. Thank you, sir.
Thank you. Good evening, everyone. I am Abhay Kumar, and I'll be taking this session. Actually, my prime objective was to impact. Everybody knows that this is a exciting field, and this upcoming area. Now another field has this generative AI has taken up. The generative AI together with IoT can create industry miracles. And what we will be doing many projects. This will be a hands-on session. And IoT has many verticals, so we'll be focusing on this hardware and its implementation through its software domain. And how to develop IoT applications and how we integrate IoT in the environment to acquire real life data, and we'll develop from scratch. Basically, this will be a session of around 30 days program, and weekly we'll have 3 sessions, and that will be on Tuesday, Thursday and Saturday. That will be only on working days, and we'll exclude holidays and weekly off days. And there is a, I hope there is a WhatsApp group, so participants can share their views and their queries through the WhatsApp group. And at the beginning of the next session, we will first clarify the doubts, and this is a glimpse of the program, the schedule that we are going to follow. And broadly it is divided into introductory topics. Then we are selecting 2 popular IoT devices. One is Arduino environment, and another is this Node MCU platform built around ESP8266. And finally, we will be using a device that is your system on chip based, that is a Raspberry Pi. And finally, towards the end, we'll be doing some projects, and we'll be strictly following the guideline how to develop and in what level we are going to develop these applications. Basically, there are 6 levels of developing IoT applications, and there are many steps when you are going to conceptualize from concept to completion. A project step, certain project development step, certain steps, around 10 steps are there. We'll outline all these steps, of course, during the project level, and prior to that, we'll have all preliminary things. So before we start the preliminary session, today we'll have some preliminary means introductory sessions. We'll start, and the reason is that you must have a desire. Why actually you are going to attend this course? What benefit you will get? That is one of the most vital things. If you don't desire, you will not get interested in this. So why we are doing this course? What is so important? Okay. So I would like to share my slides. Okay. Can anyone tell me, is the slide visible? Okay. So now our agenda is we will start with what is current IoT market. We'll have a glance look on the current situation, current scenario. Then we'll have a brief introduction to Internet of Things. Then ultimately, Internet of Things is nothing but a conglomeration of many wireless sensor networks. There are many sensor fields. Then we discuss about various building blocks of IoT. And in that building blocks, there are processing elements, there are sensors, there are actuators, there are communication infrastructure or communication devices that establishes that is they are the heart of these IoT devices, because it's the Internet of Things, and we need to share our data and get instructions through the internet. So communication infrastructures. Then power sources. So most of the IoT devices, they are self-powered. So from where they get their power, what type of power sourcings are there. So all these things we'll discuss. Then what are the development platforms? There are many development platforms. We'll have a very brief overview of all this. We'll not get deep into that. Rather, we'll focus more on hands-on and at the development side. Then finally, we'll do some IoT project towards the end. The present scenario. The global industrial IoT market with a turnover 320.9 billion US dollar in 2022 to it is going to grow up to 1,562.35 US billion dollar in 2032. So the kind of growth you can realize, so it is tremendous. With this kind of market, the next, in which sector, which user segment they are working. The key segments are agriculture segment, and the highest is the manufacturing industry. So that's why we are focusing on industrial IoT, what we call IoT. Okay. Then energy sector, oil and gas sector, healthcare sector, and what rate they are going to grow within this period of time, within 30 years. And healthcare, logistic, others, and agriculture sector. Agriculture sector is going to move to aquaculture, because it is next area which we are going to, because this UNDP 17 SDG focuses on sustainability, and in that sustainability issue, that aquaculture is one of the vital element. Now, US consumer market, it is growing at the rate of 12.2 CAGR cumulative annual growth rate from 2023 to 2030. So with this growth rate, we have got tremendous scope. Ultimately, who will do that? It is not I am not going to do that. Obviously, our next generation is going to address this market requirement. Okay. They have got a vast duration during which they will develop all these applications. They will mature with this in developing these applications for about 30-40 years. There. Now, what about our country? Now, in this, the consumer electronics sector is the highest segment, and all are consumers. So that's why this is a huge segment. Okay. Healthcare is a prominent segment in that. You can develop your expertise in specific domain, specific segment. Okay. You need not address all the segment. It's not possible. Rather, should not be. You develop your expertise. Okay. Now the consumer market, US is definitely the highest segment, but Asian country is going to be the fastest growing market. Okay, as you can see, this is the fastest growing market. Okay. So this consumer IoT market comprises of what are the segments? These are the countries which focuses on that: North America, Europe, Asia Pacific, Latin America, Middle East, and Africa. In terms of components, the key components are hardware, software, and services. In terms of connectivity, it is a wired connectivity, wireless connectivity, and mostly wireless IoT devices they work on. Wireless segment. And in the application outlook, it is a consumer electronics sector, healthcare sector, wearable sectors, and automotive sectors. Slowly we are going for more EVs, and more EVs requires a lot of IoT integration to that. So, now we'll start with a brief introduction of what is IoT. Basically, by definition, Internet of Things is a network of physical objects, or what we call them things, embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange data. They can share their status, their information, and they can take data. Suppose you want to find out what is the status of your temperature room. You are sensing your temperature. Your room is a thing from where you are collecting data. It provides you data about the temperature, and if you found the temperature is very high, and you are coming back home, so you can give a command to switch on your air conditioner. So they can exchange data. Now you are sending a control data to make the air conditioner switch on. Okay. Now IoT allows objects to be sensed. Now your home automation, your room environment allows to be sensed. Whether the light is on, whether the AC is on, whether the refrigerator is on, whether your food processor is on, if anybody is moving inside, you can sense people's movement. You can find out people's presence through camera, security surveillance camera. You can find out. Security surveillance camera can operate in multiple modes, okay, depending upon what the situation. So all this intelligence is there. So IoT allows objects to be sensed and controlled remotely. Your AC status was sensed that your AC is off and temperature is 33 degrees centigrade. You want to come back home. You want the room to be chilled. You know how much time it will take. So accordingly, you give a command. And AC knows how much time it will take. Depending on the temperature gradient, it finds out that this will take this much of time, so it will rise the temperature. Automatically, it will control that. So, remotely across the existing network infrastructure, controlled remotely through the existing infrastructure, whatever infrastructure you have deployed, through that only you are controlling. The key infrastructure is the internet connectivity. Creating opportunities for more direct integration between the physical world and the computer-based system. So ultimately, how you are controlling? There is some connectivity with your computer world, maybe a smartphone. That is a computing device now. And resulting in improved efficiency. It is giving improved efficiency in terms of, it is giving a lot of freedom, lot of flexibility. Working moms, they are relieved of their headache. They are keeping their kids home, monitoring directly through their security vision camera, where their baby is playing inside, and they are giving command, they are giving instruction. Okay, they are talking to their children. So resulting in improved efficiency, accuracy, and economic benefit. In an industry, you are monitoring remotely, finding out your status of the machines, and you are monitoring if your machine is in healthy condition. Before your machine takes a sudden breakdown, a catastrophic situation, you can find out whether your machine requires a immediate maintenance. It's going to take a breakdown. So you can find out and you can take precautionary measure. Okay. So IoT is nothing but a huge room. Here in a city, you can have a big network. There are many sensors network. There may be many things going on concurrently. If you have made an automation, your building might be simultaneously monitoring airline status, taking status of a cab, taking status about your internet connectivity, your data analytics, your industry status. Okay. At the same time, it is monitoring healthcare status, health status of people. So all these things, how it happens actually. If you look into the architectural view of it, then it appears as if it is a big structure. There are many sensor fields comprising of sensor field 1, sensor field 2, and the sensor field. They are nothing but the connected nodes, connected devices. All of them, they are sharing data with a base station. The base station sends that data to the cloud connectivity. And if you go for a blown up view of this, then this will appear. Now, when this data is taken to the cloud repository, from the cloud repository data is taken to some site where analytics is done, they can find out at what rate your industry, factories breakdown rate, what is the rainfall rate, what is your production rate, and when you are going to plan for your next production status drive for a particular device. So you can take the status of this. It can retrieve data, retrieve intelligence out of this repository through the data mining process. And since the sensor nodes are small, built on small processors, processing elements, they don't have huge processing power. So complex processing is done on the cloud. So that's the processing station. Some site is retrieves data and do the processing work. Put the data in some cloud storage. Okay. So all these things is possible through the integration of internet. Now this sensor field is nothing but a network of connected nodes, and this gives rise to a wireless sensor network. So Internet of Things is nothing but there are many such wireless sensor networks that are connected together. And all these nodes, they are autonomous, they can directly establish connectivity with themselves. if someone goes bad, they are self-healing network. If one of the connectivity is broken, they can find out another path to send their data to the cloud repository. Okay. Now, the building block behind this. Here, one thing I have not shown, that is the power element. The building block comprises of the sensor subsystem, the processor subsystem, the communication subsystem, and the power subsystem. The sensor subsystem basically comprises of integrating the sensors. Sensors are built on various technologies depending upon their kind of interface. They may be interfaced through I2C, they may be interfaced through UART, they may be interfaced through SPI bus, serial peripheral interface. Some of the devices may be sending digital data because you will be processing this data on a digital computer. So digital computer always expect data to be fed to them in a digital form. But real life physical data usually they are in analog form. If the analog data is taken, they need to be converted to digital form. So this has to pass through a signal conditioning, because the data being sensed from the physical world might be quite feeble, maybe contaminated with a lot of noise, so it requires filtration. And if the signal level is quite small, they need to be elevated, their level to be amplified. So signal conditioning basically do the amplification part and noise filtration part. There is a low pass filter because the high frequency noises are eliminated from that. Now this signal is taken to the sampling device, and after sampling we go for a quantitation, so that our AD, analog to digital conversion part, is done. So once we get the data in digital domain, we are free. We can take it to our digital computer, that is the processing subsystem. Processing subsystem takes the program, it has got a data area, it has got a flash memory for storing this data. Then other regular architecture is there. Okay, we'll have a glimpse of what is the internal architecture of that. Okay. Now this data is to be sent wirelessly. So we interface a communication infrastructure. It is a radio communication device built on many technology, maybe Wi-Fi, maybe Bluetooth, maybe infrared, maybe LoRa, maybe Zigbee. Many technologies, many protocols are there. All of them, they require some mechanism to transmit this, maybe antenna. Okay. Now these communication subsystems are connected to the processor, takes the data, and they receive the data and give it back. Some remote system sends some command, so that the command will work on the physical world. You are giving some command and you want to operate some actuator. In that case, your communication infrastructure will receive the data. It is in analog form, and that will again will go to this system, and command will be given. Now, let's have a look at power subsystem. We'll see afterward. Now the processing element. Basically, the processing element, what it comprises of? It senses the data. For real world, we sense some process. That is a process. Now health band. Health band is act as health band is a sensor. But it monitors which process? It monitors our physical process, our physical system. It senses what is your pulse rate. When your pulse becomes abnormal, senses this data, sends it to the gateway. It is connected to your cell phone. Cell phone is the gateway. Gateway is connected to your health advisor. Without your knowledge, your health advisor receives a signal. Mr. Das, your temperature, your beat rate is fluctuating. You please take rest, don't move. You will get a phone call. You will get surprised. How? I have not informed my health advisor, how I am getting this message. Because this is what the IoT. Okay. Any situation goes, before it becomes catastrophic, you will get a warning message. Now its sensor senses the data, passes through the conditioning device, then passes through the analog to digital conversion, then goes to the signal processing unit. Signal processing is nothing but your processor element. And then it sends, and when it receives like some command, then again signal processing unit is involved. And since it is a command to be acted upon the physical world, so they will send the data to a digital to analog converter, because inherently the real life world is an analog world. Now that command will go to the conditioning device. Now the voltage level has to be improved, because you want to operate some actuator, some electrical device, some air conditioner that will operate at a high voltage, and your sensor node might be operating at 3.3 volt or even 1.5 volt. And if that is going to trigger a heavy electrical motor or device, then there must be adequate signal conditioning device. And that signal conditioning device gives command, gives voltage, gives operation, gives instruction to the actuator, so that actuator will operate. Basically, this is the role of the processing element in the IoT system. And there are various types of processing elements. The processing elements, normally we call them single board computers, built around some microcontrollers. One of the most popular is ATmega 328PU, which is the heart of this development board. Arduino Uno is a development board in which the processor is ATmega 328PU. Next popular is Node MCU. Okay, Node MCU development board, and Node MCU stands for Nodes Microcontroller Unit, MCU. Okay. Wemos D is another same, built around the same processor or same SoC. Here the microcontroller is ESP8266. There are many variants of the ESP8266. The specific version that is used in Node MCU Wemos D one many as ESP8266-12E or 12F. The next is ESP32 Node MCU. This is a relatively higher version of this ESP8266 from Espressif. The company which has released this is the Espressif. And there are many other vendors, those who are supplying the same. Then the Raspberry Pi. Raspberry Pi is a full system on the board. Okay? It's a complete system, complete computer. Some variants of the Linux operating system, Raspbian is nothing but a variant of Linux operating system that is installed, and we call it Raspbian, and now we are calling it Raspberry Pi OS. We'll see all this. We'll install a Raspbian operating system on a Raspberry Pi board. Another popular is BeagleBone Black. It directly operates on Linux operating system, open source board. Then STM32F103C8. This is a industry choice microcontroller board. That also we'll see. Then there are many other popular boards. Many processor boards, they come in 8-pin DIL, 8-pin chips, and you can interface hundreds of devices with that 8-pin device through I2C interface bus. We'll see how we can interface multiple devices only through the 2OS. Okay. Then how to select the right development board? Now question is, if there are so hundreds of boards are there, which board should I select? There are many factors. What is your requirement? Because you will definitely not select a heavy computer. You will not take a cannon to kill a mosquito. So you will find out what is the best suit for my purpose. If some purpose for which Arduino is enough, then definitely we will not go for Raspberry Pi. Okay. So what is my application domain requirement? What is my future upgradability? Now I am building it with Arduino, but there is a possibility that it may expand in future, And if it expands, then my Arduino will be insufficient. Then why to reinvent the wheel again? So you design it now, put it in lower scale, so that it has got a scope of scalability. You can scale it up to a higher version. But at least your application platform, application framework remains the same. Next. Sensors. Basically, what is a sensor? What is a sensor? Is a device that senses physical and data from the physical environment. There are varieties of types of sensors. They differ by their technology. If you are collecting the same physical data, you are sensing temperature. There are many technologies are there. Okay. Now you are sensing temperature. You can use a passive device. You can use an active device. There are many active devices are there. 18B20, it is a temperature sensor. LM35 is a temperature sensor. A thermistor is a passive temperature sensor device. Okay, that differ by technology. Okay, differs by how they sense this data. Some of them supply data in analog form. Some of them supply this data in digital form. If you are going to DHT11, a digital humidity and temperature sensor, they supply this temperature in digital form directly. Whereas LM35, that will provide temperature data in analog form. And you can identify them on the basis of their specifications. Interfacing sensors with SBC. How you are interfacing these sensors with SBC, that is also a vital aspect. Whether you are connecting a sensor to the board, if this is a board, how you are connecting it? Directly through their GPIO lines, general purpose IO lines, or if you are connecting it through general purpose IO line, then you can connect one sensor to one line. Multiple, you can't do that. If you want to interface multiple devices, you have to go for a bus, and there are many interface buses. Okay, two popular interface buses, one is SPI and another is I2C. Now IQC has come out. Improved I2C, that is IQC. Okay. Of course, devices in the market probably they have not arrived. I don't know. I have not seen it, but that has come out. So there are varieties of interface bus. How you are interfacing that? Some of them they are connected through serial bus. Some of them they require parallel interface. And a single device can be interfaced in many ways also. For example, one LCD, 16:2 or 20x4. These LCD modules you can connect in a parallel mode. In half mode, you can use 4 wires to connect them. If you want to, but in that mode you cannot connect multiple devices. If you want to connect multiple LCDs, then in that case, you may have to go for some bus interface. So through I2C interface, you can connect multiple LCDs. So we'll see all this as a part of the course. Next is smart sensors. Now, you know that if your temperature goes above 30 degrees centigrade, it is hot. And you have fitted a temperature sensor. A temperature sensor is displaying data. 18 degrees centigrade, 22 degrees centigrade, 33, 25, so all this. A person who cannot read, will he make sense of this figure? It is meaningless. Now if an intelligent sensor you have fitted, now that intelligent sensor, depending upon the temperature, it will change the color. If you have fitted a humidity sensor, it is sensing humidity and environmental condition and giving a signal and making a prediction that this will be a humid day. So intelligent sensor directly gives you the data that what you require, not without using any computation directly. Actuators. Actuators, they're just opposite of sensors. They collect data from the physical environment, and actuators make action in the physical environment. You are operating a motor. A speed sensor will sense what is the motor speed. But a command to control that, a electrical clutch, to apply a brake, to switch off the motor. So all these are part of the actuator. Switching on and off, there may be a relay. There are many technologies on the basis of which you can switch on and switch off. Relay is nothing but an electromechanical device. You can use a solid state relay built out of, might be in a AC circuit is different, might be a track. In a DC circuit you might be using a SCR, or you might be using a MOSFET. You might be using a IGBT if the current level is very high. So there are different technologies, same for the same purpose, depending upon the type of nature of application, nature of load you are going to handle. So different types of devices are there. There are many types of actuators. So what actually actuator is? So the actuator, it gives some plate, makes some action. There are many types of actuators. Their technology also differs. Okay. Applying a brake. That brake varies. Whether it is a electrical, whether it is a mechanical, magnetic brake, what type of brake are you using? Their technology and their specifications varies. Interfacing SBCs with interfacing these actuators with the SBC, there are many types of interface. Some device, they require huge current to operate, which your SBC's GPIO current will not sufficient. You require a current booster. In some case, your actuators require high voltage to operate. Your GPIO will not be sufficient. LED is also an actuator. It gives a signal, it gives a buzzing, gives an alarm, or a buzzer. They require very little current. They can be directly connected to the IO lines. But a heavy motor, heavy switch, a contactor, electrical contactor, you cannot operate that with direct GPIO line. Either you require some interface, for example, connecting a stepper motor, you require a motor controller. Okay. So according to the type of interface varies, we will see all this. Now, programming the SBCs to drive the actuators, you need how you are going to control that. Okay. Different SBCs require different formalities to how to control that. Controlling a DC motor is different. Then the way to control a BLDC motor, then to control a stepper motor, and controlling a servo motor. Their control systems are complete. Okay. The programming ways are different because of their technology involved. So only we'll discuss about their technology involved and what is their principle behind their operation. Okay. Communication infrastructure. They are the heart of the IoT system. So communication infrastructure, they establish connectivity with the remote world. Okay. How we send our data wirelessly? There are varieties of communication infrastructure, varieties of technologies. So types of communication infrastructure, their technology, their specification varies depending upon the nature of application. And it varies from countries to countries. For example, we are going to select this LoRa. LoRa in Asia, some candidates, it is allowed is 868 megahertz, whereas in US, you can find out 433 megahertz is allowed. Different countries, their RTI, they have given restrictions on that. Okay. Interfacing communication infrastructure with this, we will do direct interface of this varieties of communication infrastructure with our SBCs, and we will do our project. At the time we will discuss in depth. Programming the SBCs to integrate communication infrastructure with IoT solution, a home automation system. We will use a Wi-Fi and it will establish connectivity with our cloud network, our internet cloud, and the application might be running in our smartphone, and I want to operate the fan, operate AC, operate lights. Directly I can do it from my program. So this kind of interface, okay, we can take. So there are many kinds of many varieties. Yes. Power sources. Sourcing IoT projects. Okay, how to power source this IoT project is a vital component. There are many ways we can provide a fixed battery. We may provide an uninterrupted power source. We can provide source how the charge level, once you deplete it, automatically you will get replenished. We have fitted some anemometer, and that anemometer is supplying data directly. We are not laying cable, long cable. It is wirelessly, it is sending my data. But it is fitted on top of my 3 stories building. And it is on top of that, top of the roof. There on the headroom, I have fitted another 20 feet mast. On top of that, is it possible to climb? No. So it is sending my data. But what about the power? I fitted a battery. And I had a planning that it will run for 5 years. So how the charge will get replenished? In that case, I may put a solar cell. So once the power level goes down, automatically the battery level will be charged. It will be recharged by solar. Okay. And I have made my battery level such, and simultaneously I am monitoring. From my remote device, I am monitoring what is the battery level. Oh, it is going to be rainy day for 5 days. So within 5 days, I am not going to get sun. It will not be sunny. So my solar power system will not replenish. But what is the level of charge available? Will it run for 5 days? My system will tell yes, because the analytics is there. It will find out. And it will tell me, oh, don't worry. It will run for 20 days. Okay. 20 days no sun will never happen. It definitely will happen. Okay. So all these things are part of that. So types of power source that differs. We can have uninterrupted power source. We can design it. Development platform. There are many development platforms, and basically there are 4 stages. And we'll do directly this. The first stage of development, of course, the input comes from the things. Depending on what thing we are going to sense, the sensor will differ. Sensor will depend upon what we are going to sense. We are going to sense climate. We are going to sense status of toys. We are going to sense status of some construction parameter, might be a health monitoring. We are monitoring a building, structural health monitoring. We are going for customers monitoring. How many customers are there in my mall? What they have purchased? What the customer is looking for? What the customer is putting in bin? We are trying to sense our motors. Might be motor speed, motor vibration, motor voltage level, motor temperature. We might be monitoring humans. How many persons are moving in this room? How many persons are present? We can sense that. We are monitoring the tool status. Okay, might be there activated with some sensors. We can find out their status. We are monitoring our appliances. Might be I'm monitoring my AC, monitoring my refrigerator, monitoring my washing machine, my food processor, all these things I'm sensing. Then the fastest, once you sense this data, then my fastest is sensors or actuators, how they are connected. Of course, they are wired to the system. They are part of the IoT device. Okay. They may be connected through wire or maybe wirelessly they are connected. The next stage is, once the data is accumulated, once the data is collected, how they are connected to the internet gateway. Either they may be connected to this device, maybe through infrared, maybe through Bluetooth, maybe through Wi-Fi, maybe through the internet. There are many ways. So what approach we are following? Okay. So their data, why you need that? You need to send this data. Okay. And once you have converted, there may be eddy conversion measurements, there are control. So all these actions are in the stage 2. In the stage 3, as IoT, we perform analytics. Why you do analytics? Because these devices, they don't have tremendous computing power. They are very low footprint computing devices are there, 8-bit processors, and do minimum thing, collecting data and sending it, that's all. They can do heavy processing load. Okay. So it goes to cloud, and from cloud we do some processing, do some analytics, do some data retrieval, do some filtration, and we send it back. Then this data goes, the validated data, the authenticated data goes to the data center and cloud storage, there we keep it. So basically how we'll organize this, that we'll see in the 4 stages of IoT solution architecture development, we'll see that. There are many development platforms, maybe Google Cloud IoT platform, thingSpeak, there is another IoT platform, Amazon Web Services platform for IoT, ThingsWorks, Microsoft Azure IoT platform. There are many IoT platforms are available. Some of them are free IoT platforms, some of them are paid IoT platform. Some of them they provide a high level of security. Okay. Then IRA Veracity, Oracle IoT, IBM Watson IoT, there are many IoT. The IoT ecosystem, the environment, the framework that provides all things that you need for development and deployment of IoT solutions. This is a combination of various IoT layers, beginning from the user layer to the connectivity layer. Might be internet connectivity, the cloud, all these infrastructures are available. The users are there. Okay. Key components of the IoT ecosystems, they are sensing and embedding components. So sensing devices, the actuators, they are part of that. In the connectivity layer, we talk of the protocols. What protocol, whether it is IPv4, IPv6, whether it is Wi-Fi, whether it is LoRa, whether it is Zigbee, what are all these protocols? And what gateway you are using? What type of gateway? Whether it is IP enabled or it is IP free. If I am using internet gateway, then obviously it is IP based. If I am connecting through Wi-Fi, LoRa and other things, they are non-IP based. Then analytics layer. In analytics layer, we do many things. We extract information from it. We extract predictive data from that. We make predictions. Okay, when you analyze the data, we get intelligence out of it. In the data management layer, we collect the data. We extrapolate, if there may be some missing data, that we fill it. We keep the data for historical purpose. so that they can be used in future to predict a trend or trend analysis. Maybe my data, all these data are time series data, my rainfall rate, my customer utilization, customer inflow, so how it is growing. So I can predict how my business is going to act after 2 years. I can find it out. End components are the smart devices. Directly they can decision. Now you have connected a security vision camera. A smart security vision camera will keep on tracking. If some person enters into there, it will keep on tracking in which direction they are moving. If no one is there, they will sit coolly. Now, if the same person sits for 5 minutes, then they will think probably this person belongs to this environment, so that fellow, this fellow is keeping cool. So now he will know what to track you. If a new person, again he will start tracking. These are smart devices. They take smart action. Development platforms are designed for IoT solutions. Now, IoT development, broadly we divide into physical IoT and the logical IoT. In the physical IoT segment, all the devices. Physical IoT, the IoT things. The processor, connectivity means communication infrastructure, memory devices, graphics, power, I/O interfaces, all these things, they are part of the physical IoT things. Now the logical, the protocols, yeah. Protocol is nothing but a two agreement. So they give network connectivity, device connectivity, localized protocols, then time synchronization protocol. Okay. Then many security protocol, MQTT is a security protocol that we use when we are sending this data, authenticated data transfer. Then the protocol operates in very because we follow a layered approach. This layered approach, we start with physical layer from the bottom, then go for the data link layer, then network layer, transport layer, then application layer. And all these defined responsibility, layer responsibility is well defined, very clearly segregated. Now about logical IoT, this is where the application interface is about. And there are many models. Request response model, publisher software model. Okay, MQTT is based on this publisher software model, push pull model, exclusive pair model, REST based API, web socket model. That while developing application will explore all this. Okay. Then web socket based programming paradigm for application development, web application development, and data handling using JavaScript, JSON, okay, Java server object notation. And finally, we will do IoT projects. So, here we conclude our introductory presentation. Go to the next one. What's the time?
6.
Huh?
6.
6. So, we'll enter into the next.
So, thank you, sir, for sharing this wonderful session with us. So, I would request if anyone have any doubts, they can directly raise their hands or open mics to say, or they can put in the chat so that we can have clear your doubts. So before that, we already have a doubt in the event query that what is the advantages and disadvantages of generative AI in IoT field, if you can clarify on that.
In fact, generative AI and IoT in general, they are two promising field and evolving fields of current time, and they are having significant impact on various domains, various industries. This generative AI involves artificial intelligence algorithms to generate novel solutions, novel contents, such as images, maybe text, maybe other forms. Okay. And on the other hand, IoT, they refer to how to network physical components so that we can collect information from them, like buildings, like embedded with sensors, then software. technology, all these are connected. Now this combination of generative AI and IoT, they come up with marvelous things. Generative AI integrated with IoT can come up, design a personalized information system. If they can create a personalized experience. Okay. So there are many advantages that will come, but at the same time there are many challenges to be faced. Okay. So some of the significant challenges are combination of AI and particularly the areas of security. There is a lot of security threat. Okay. So how to address that threat? Okay. So these are the challenges, at the same time benefits. Okay.
Thank you, sir. If we have any more questions, you can put it in the chat, or you can open the mic and say it. It would be better. And on the audience sitting over here, they can also ask the questions. It's open for everyone. And I want to say that there is the WhatsApp link to the group in the chat already. If you are interested for any further sessions which we are going to have, so you can join it over there in the WhatsApp group, and the link will be shared every day to you for the session. It will be in the alternative days, as sir said, in the working days, not in the holidays. So we can have it, and so if anyone have any kind of questions, they can ask it. Any questions? No. If everyone can turn on their cameras at the end, we can have a screenshot of it. It will be good.
So I'm stopping this.
Yes. If everyone can turn on their cameras, please. Okay. With this, I conclude today's session. It's a nice session by sir. I hope we all will join in the next time in the next session. And I enjoyed this one and hope the hands-on session will be more useful to us.
Definitely. This is basically a hands-on session.
Yeah.
And there are many things to
Explore. Correct. So I hope I hope that everyone will meet in the next session also. So till then, bye bye. Thank you for joining everyone. Thank you, sir.